All right, so what I would like to do is talk about 6.5. So 6.5 is going to go back to graphing a little bit. Okay, 6.5 and 6.6 use graphing techniques. I said we're close to being done with graphing.
After this, we're done?
What we learn here, the procedure that I show you is we're going to add 2 steps to graphing. Okay, one of those steps is that we're going to decide what kind of line we use, whether we use a solid line to graph or a dotted line. Okay, and then we're going to decide whether we color above the line or we color below the line. Okay, now I want to make sure we understand that we're not just trying to add aesthetics to our picture for no reason. The shading that we do or coloring that we do and the fact of choosing a solid line or a dotted line has a link to solutions. Okay, so I'll make sure we talk and discuss that. I don't want you just to learn the process and how to do it, but I want you to know what we're doing and what the results really mean. When we have a finished image, what does the colored region mean? What does the dotted line mean? That kind of stuff. Okay, so we're talking about linear inequalities. Inequalities are when things are unequal, right? Okay, inequalities are when things are unequal. A linear inequality is created by taking a linear equation, so something like y equals mx plus b, okay, and instead of having an equal sign, we replace it with the less than greater than, or less than or equal to, greater than or equal to signs. Okay, that's what the definition, when you hear me say linear inequality, that's what we want to think. Okay, it says a solution of an inequality is any ordered pair, x comma y, that will satisfy the inequality. That makes the inequality true. Okay? So that is what we're going to use. That logic right there is what we're going to use to actually decide on some choices here in a little bit about where to color and what our solutions mean, that kind of stuff. The little bullet here says determine if x and y make the inequality true. You just substitute. You take the x's and y's for the ordered pair, and you plug it into your inequality, evaluate both sides. You'll be left with 2 numbers that are being compared to one another with an inequality symbol. You have to answer, is it true or is it false? And when we answer with those 2 results, I'll tell you what you do if it's true, and I'll tell you what you do if it's false. If it's true, it means that point is a solution, and we'll want to somehow identify that it's a solution. If it's false, it's not a solution. Okay? So I line up here some steps. I think there's 5 steps here for us, and this is just an introduction. We'll add to these because of the way that the problem might be presented to us later on in the week. So these are steps for really our early on type of linear inequalities that we're going to graph. Okay. First thing says graph the inequality using either y equals mx plus b or the intercepts method. Okay. So y equals mx plus b is my point slope formula, right? Or sorry, slope intercept formula. Slope intercept formula. Okay. So I plot my y intercept, then I apply my slope to that, and I get another point, and I graph it, right? The intercepts technique is going to be used if they give me something that looks like this here, where it says ax plus by is less than c. If it's in standard form, I use the intercepts technique, which says let x be 0, solve for y. Then let y be 0, solve for x. You got 2 points then, plot those 2 points. Okay? So what we're doing here, steps 1 and essentially steps 1 and kind of step 2 are things that we've learned in sections 5.1, 5.2, and 5.3. Okay? Yes?
You think that we learned this
You may have looked at it a little bit last year. Huh? All right, so steps for graphing. Okay, so we're now here at step 2. This is one of the differences between what we've done and what we're going to do. If you are going to use that symbol or that symbol, so less than or equal to or greater than or equal to, you're going to graph with a solid line. Okay? There's 2 ways of remembering this, okay? One way is that if you have this line underneath, that line underneath means the equality aspect, right? If we have that line underneath, you can remember, well, that's a solid line, so when I graph my line, I make a solid line. Does that make sense? Okay. If we go and graph with or our equation has this symbol in it. If it's just less than or just greater than, you are going to graph with a dotted line. So that's going to look this way. Okay? What that means is that when we graph in these lines, the solid line means any point that is on the solid line will actually be a solution to the inequality. Okay? Because it's actually going to be the equality aspect of the inequality. Okay? If I ever graph a line with a dotted line, it means that any point on that dotted line is not a solution to the inequality. Okay? The way I remember solid or dotted, when I was your age, what I did is I did this thing. It takes me more ink to draw that symbol than it does to draw that one, right? That makes sense? More ink to draw that one than it does to draw that one. So then when I draw the lines, this line needs more ink than that one. And I write that at the top of my page, and then I remember equality involves the solid line, inequality or non-equal means I've got to use the dotted line. Okay. If you like the idea that there's a line in this one, in this image, this symbol, and it's a solid line, then that's a solid line. That's another way to remember it. So somehow link them, because you can get these wrong. You can do everything right, but graph the wrong type of line, and the whole thing be counted wrong. Does that make sense? Okay. Step 3 says if the inequality is in y is greater than mx plus b form. So it says y is greater than. Okay. That means what we'll be doing is looking for y values that are above or greater than the line that you have just drawn. So if I've got a line here, okay, so here is my line right now, okay, would you guys agree that, let me just remove this to an equal sign real quick. That didn't do it. Equals. Well, we'll do that. Okay. If I look at this line right there, okay, graph it just like we've normally graphed lines, right? From my y-intercept, use my slope, get these 2 points. So there's my line right there. Maybe it makes more sense to maybe look at, so y-intercept of 2, from there, up 1 over 2 gives me b, right? Okay. If this were going to be an inequality, and I wanted to shade above this line, okay, the inequality would look like this. Okay, it says y is greater than the line. Does that make sense? So I find my line, and I think, okay, where are the y values that are above that or greater than that? Does that make sense? Would you agree that all of these are the y values that are above it? Yeah. Okay, so what we end up doing then is once we decide that, we shade everything that is above the line. Does that make sense? Okay. We have to shade everything that's above the line. Now that is if the y comes first. Y is greater than mx plus b. We're going to shade above. I think it's always a good idea to make sure that your y is written first. Because then you say, well, that means greater than, so it means above. And I shade above. We're going to have to do that, yeah. Okay. So in Math Excel, it's going to pop up like a interactive tool that you can, it's got that paint can on it or whatever, and you got to kind of click on where you want it to paint or color. Okay. So we would shade above. Now, what I told the last class is if I can't figure out where to shade, what I like to do, and this is because the lines eventually get steeper and it's harder to determine. What I like to do is I like to take a stick figure. Okay? And if that's my stick figure, I'm hanging them up here and I'm going to drop them.
That is not nice.
And when I drop him, he's going to land right there. Does that make sense? He's not going to get beyond that line. And now his body would be above the line. Does that make sense? And if I need to shade greater than, I shade above. Okay? If I need to shade less than, I shade below. So this tells me where he lands, tells me the top of the line, and then obviously shows me where the bottom of the line is. Does that make sense? Okay? The reason I do that is because when I get lines that look like this, okay, it's hard to determine where's the top, where's the bottom, because that line is getting closer and closer to being vertical, right? Does that make sense? So what I do with that, okay, I take my little guy and I drop him, and when I drop him, and after that one, he's going to stop right there, right? Touch the line, and now where he's at would be above the line, and then this would be below the line. Does that make sense? Okay. It looks more like a left of the line and right of the line, right? Okay. But we're still talking about greater than and less than, so it makes sense to do that. There's another way algebraically to do it, but if you're going to do it visually, I think that's kind of the best thing. All right, so if it's less than, you're going to shade below. So looking at this here, if I make that a less than symbol, that's below the line. Makes more sense when it's more of a shallow slope, right? You can kind of see the plane being divided into a top and a bottom. But this would still be top over here. This would be bottom over here. Okay, everybody? Okay. What this means, it says all shaded regions represent x, y's or ordered pairs that satisfy the inequality. That means that they make the inequality true. Okay. Step 5 is something that we'll come back to later on, okay, because it tells me what I do if the equations were not given in y equals mx plus b form. Okay. So we'll come back to this when we see an example of that. So I want to just skip down to the bottom there. It says note, points that are on dotted lines are not solutions. I don't understand. And points that are on solid lines are solutions. So that's something to keep in mind as we progress through this. Okay. So when we see an example, that's what they're going to ask you. They're going to say graph this. Okay. So the first thing we do is we're going to graph it like it was an equation. Okay. Don't even worry about the inequality sign right now. Let's just go find the y-intercept and apply the slope to it. So what's my y-intercept? -2. So I'm going to find that point. Okay, and then from there, I'm going to apply my slope. So from there, my slope is going to be what? Up 1, right 1. I can do that as much as I need to. Okay. What do you mean by, so all lines are straight? Solid. And that would be solid because of that right there, right? That inequality symbol has equality involved with it. So that tells us that when we connect these dots, we're going to do it with a solid line. Now, I'm kind of bad at actually connecting the dots, but you get the idea. Okay? Say again? So that's part of it. There's one more aspect. So that's really the same thing we've already been doing, right? Okay? Now, the way we read this, it says y is greater, right? If I read that left to right, y is greater. So greater means shade above. Does that make sense? Okay. So if I put my stick figure guy in here and drop him, is he going to land like right there? Does that make sense? And he's going to land on the top of the line. He always lands on top of the line. So I'm going to shade this stuff here. I'm going to shade as much of it as I can, obviously, but is that okay? All right. Now, if you're doing this with pencils and stuff like that, eventually in section 6.6, we'll do this with two equations or two inequalities. And it gets kind of confusing because we're going to use two different colors. But right now, just one. So if you want, like, use a pen, obviously, if there's only one color, you can use your pencil and just shade it gray. We're going to use colored pencils, markers. Some people like highlighters. Your choice. But now let's talk about what this stuff means. Okay? All of these blue points then, anything that I just colored over the top of. So if I look at like this point right here, that point's ordered pair is 3, 1. Does that make sense? And that means when I substitute over here, y being 1, x being 3, okay, I should get a solution that is what? What do you say to this? Okay, they're equal here, so is that true or false? Is 1 greater than or equal to 1? Is 1 greater than or equal to 1, right? It's true. I only got to satisfy one of those. I either got to be greater than or equal. So that's true, okay? If I try a number like, or an ordered pair like this, let's go -3, 5. So y is 5, x is -3, and then subtract this 2. When I evaluate that, 5 is greater than or equal to -5. Is 5 greater than or equal to -5? True or false? True. Okay? Any one of these points that I pluck out of here that is going to be in the blue, when I plug it back into the inequality, I will get a true statement. Does that make sense? So that means that those are all solutions. So we have an infinite number of solutions. Does that make sense? Okay. Now, when I pick, and this is the idea of a solid line. If I pick a point like this point right there is 3, 1, right? I messed this first one up totally, didn't I? Is that point 3, 1? No, it's 1, 3, right? So let's do one. Let's just double check, make sure we got that work. Idiot. 1, 3. So if y is 3, x is 1, minus 2, is 3 greater than or equal to -1? Yeah. Yes, still true, right? Okay. So it's still a solution. Let's try. Let's just try this point right there. If it's on the line, right? When I choose a point that is on the line, so the y value of that point would be 0, right? 0 greater than or equal to 2 minus 2. Is 0 greater than or equal to 0? Yes, that's true. Okay? If I choose this number right there, that word pair right there, -2, -4. You'll end up with, so y is -4, and then I have -2 minus 2. What's -2 minus 2? -2 minus 2. -4. Is -4 greater than or equal to -4? Yes. Okay? What are you recognizing, though, for these points that are on the line? What do you recognize about that number compared to that number? Or that number compared to that number? They're the same, right? So whenever you, with any inequalities, when you choose a point that is off the line, okay, or came from the line, you're going to get a number then greater than or equal to, or less than or equal to, or greater than, or just less than, to the same number. So I'm going to get 0, some inequality symbol, 0. I'm going to get -4, some inequality symbol, -4, okay? And that's going to be true no matter what thing I pick off the line. Does that make sense? Okay? Now, if there's equality to it, that means it's a solution. So that's why we make this a solid line. So the solid line tells us that that was indeed a solution for the original inequality. Okay? But if it was a dotted line, that's the visual to tell you that you'd be comparing, like you'd be answering the question, is 0 greater than 0? Or is -4 greater than -4? And the answers to those would be no, right? Okay? So the solid line tells you that things that come off of it work for the original inequality. The dotted line tells you that things that comes off of it don't work for the original inequality. And we'll see an example of that here in a moment. So let's go to this one here. So this is an inequality that is just greater than, right? There is no equality here. So what kind of line would I be using here? Dotted line, okay? So find your y-intercept. -3. And then where do I go from there? Up 2 to the right 1, right? Up 2 to the right 1, up 2 to the right 1. And now you said it's a dotted line, right? And again, this says greater. Y is greater. So greater means, I drop this guy on, it's going to stand right there. Y greater than means shade on top, correct? So I'm going to shade on top. Get a bigger highlighter here. Okay. Now what I want to do is I want to choose, it kind of walks me through just checking to see if some things are solutions. This point right here, 0, 0, is that in the green? Yeah, so that means it's a solution, right? I just want to double check algebraically to see why we consider it a solution. If I plug y to be 0 in, x to be 0, I get that statement there, right? Just plugging that number in with 0, that number in with 0. Does that say 0 is greater than negative 3? Would you guys agree that 0 is bigger than negative 3? Yeah. So that's true. So that's why we shaded where 0, 0 was. It needs to be part of my solutions. If I try negative 4, 4, negative 4, 4 is right there. Visually, it's a solution, right? It's in the green. Let's plug it into my inequality. If I put y was negative 4, or sorry, y was positive 4, y is positive 4, is that greater than 2 times negative 4 minus 3? What's 2 times negative 4? Negative 8. What's negative 8 minus 3? You owe me $8 and you borrow $3 more from me. How much you owe me total? Negative 11. Negative 8 minus 3, right? Going further to the left on the number line. Would you guys agree that 4 is greater than negative 11?
Yeah.
That's true, right? Okay. Let's choose, now I say 2 negative 3. 2 negative 3 would be right there, right? Is that in the green? No. So it shouldn't be a solution. So let's see what happens when we plug things in algebraically. We had negative 3 is our y value. Is that greater than 2 times 2 minus 3? So negative 3 greater than, what's 2 times 2 minus 3? It's going to be 1, right? 4 minus 3, right? Is negative 3 greater than 1? No, that's false. Every point that is down here that I didn't shade green is going to give me a statement that is false. Does that make sense? Everything that I shade in green is going to give me a true. Does that make sense, everybody? Okay. Now, 2, 1. 2, 1 is the next one I want to check. 2, 1, is that point on my line? Yes. And my dotted line tells me that that should not be a solution, right? Here's the reason. If I plug in 2, 1, so the y value is 1, is that greater than 2 times your x value minus 3? Because this was the equation, right? The equation or the inequality was y is greater than 2x minus 3. So I'm plugging in 1 for that y, 2 for that x, because of that point, 2, 1. And now I want to evaluate. What's 2 times 2? 4 minus 3? 1. Is 1 greater than 1? No, that's false. Every point on that dotted line is going to give me something like 3 is greater than 3, or 5 is greater than 5, or negative 10 is greater than negative 10. Does that make sense? It's going to give you the same number greater to the same number, and they're not. That's never true, okay? Any number is never greater than itself. It's equal, right? So that's what dotted lines are representing, is that will not work for the original inequality.
So what's your negative 3 code when you're trying to find the solution? 2 negative 3 is negative 3. 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 2
Here?
Over, like -3.
So this -3 here?
Yeah.
So that was part of the, go back up to the original inequality. Wasn't the inequality y is greater than 2x minus 3? Does that make sense?
Yeah.
So it's at -3 is just after I just put in the numbers there, and like maybe before it you would write like y greater than 2x minus 3. Y ended up being this 0, x ended up being that 0, and then I got my -3. Is that right?
Yeah.
Let's do one more. You guys do the one. Actually, do the second one, the one there on the right. 1/2 x minus 3. Yep. Just get something that looks like that. First point you plotted was -3 on the y-axis. And you went up 1 over 2 from there, right? And I just kept doing that to get more points to make my line with. And once I make that line, because it was equality, I make it solid, right? And this says y is, what's that symbol mean? Less than. Less than. So you see how I shaded where the y values were less than or below my line? These y values here are all below that line. So that's why I shaded that entire thing. Okay. Just something real quick, and I'll leave you alone. What if I wrote this? Let's go 1/2 x minus 3 is greater than or equal to y. What do you think I'd shade if I wrote it that way? Huh? So that will produce the exact same thing that this is. Okay? Because it just flipped. But when I read it, when you read it left to right, you read it as 1/2 x minus 3 is greater than or equal to y, right? Well, 1/2 x minus 3 is the thing that generated the line, right? So basically say, okay, the line is greater than or equal to y. Well, where would I shade so if the line is greater than or equal to these y values, it would still be this stuff here. Does that make sense? The only time that you can use this to say that that means below or means above when you're shading is if your y comes first. Does that make sense? So if they gave you something like this and asked you to conduct this process, I would flip it and rewrite it this way so that you don't inadvertently shade in the wrong place. Does that make sense? Okay? So shading on top and shading below, if you're going to use that phrasing, simply only works if y is written first. No new homework tonight.